Okay, so we want to prove this equality. So the important thing when we're doing a proof is that this is not proven yet. Okay, so we can't say that this equals is true until we've actually shown that it is. So I'm saying that because this is not an equation. It looks like an equation, and it's possible you could approach it in some ways like an equation, but it's important to note that you can't actually make this statement until I've proven it at the end. Okay, so I've got sine to the 4 alpha take cos to the 4 alpha is equal to 2 sine squared alpha take 1. So what I'm going to do, I'm going to take one side. I'm going to take, in this case, I'm going to take the left-hand side. So, and usually I look for the bigger side. So if one of the sides looks very small and the other side is a bit more expansive, I'm going to take the larger side and try and basically simplify it down to see if I can get it looking something where I can make a link and go, left hand is equal to right hand side. Okay? So has anyone in Math C done proofs? Have you done proofs in Math C? So you sort of know what I'm talking about. So I'm going to start with the left-hand side. Sine of the 4 alpha take cos to the 4 alpha. Okay? Now I need to do something with this. Okay? But that keeps it the same but changes what it looks like. So here, now we've got to remember, think back to year 10, and we've got a couple of expansion patterns that are going to come in handy here. Okay? So by an expansion pattern I mean difference of two squares, a perfect square. Okay, because basically it would be nice if I can simplify this down and cancel something out. So does anyone have any idea what I'm going to do with this? I'm just curious if anyone can pick up on that yet. No one? That's fair enough. It's the first one you've seen. So, okay. So I've got sine to the 4 alpha take cos to the 4 alpha. What identity does that look a little bit like? It kind of looks like my Pythagorean identity. Okay, so it looks a bit like, I just write over here, sine squared. Oh, it doesn't. It's got that minus. Well, it looks like sine squared plus cos squared equals 1. So if I find this somewhere, I can just make it equal to 1. Okay, you could think of an identity as a substitution I can make. If I see this somewhere, I can replace it with that. We all good there? Okay. So now this is, let's replace this. What if I do this? If I make that a sine squared alpha, that's sine squared alpha, what is that to the power of? 2. So I've got sine squared alpha squared take cos squared alpha squared. Now, what expansion pattern is that? I've got a subtraction, which is a difference of 2 squares. So what's my expansion pattern for difference of 2 squares? If I have a squared take b squared, does anyone remember this? No, that's a perfect square. Yep. You remember this? A plus b, a minus b. So this is an expansion pattern you need to know. Okay, and a few are going to come up and we're going to need to know them. I'm very sorry if you don't like that, but that's the way it is. So, now in this case I've got something squared takes something else squared, so I can use my expansion pattern here. So if I've got something squared takes something else squared, I can go, well, that's something plus something multiplied by something takes something. So I can do this. I can go, well, this is obviously, maybe not obviously, but anyway, sine squared plus cos squared alpha multiplied by sine squared alpha take cos squared alpha. Now that sort of helped a little bit. Why has that helped, actually? I'll throw that question out there. Why is that an improvement on what we had? Yep. That's right, this part here, that's equal to 1. Okay, so really I have sine squared alpha take cos squared alpha. Okay. Now I'm going to compare what I have now. So this is the left hand side. Okay, that's not the only thing I've touched. If I look up here at the right hand side, that is, I have 2 sine squared alpha take 1. So what sort of a significant difference that I have between these two sides at the moment? What sort of functions do I have in this that I don't have here? I have this cos squared alpha. Now do I have anything that I can replace a cos squared alpha with? Have a look back at our identities. That's right, this one here. We have this identity here. Cos squared theta is 1 minus sine squared theta. So that's our Pythagorean identity again. So anywhere I see a cos squared, I can replace it with 1 minus sine squared alpha. So I have sine squared alpha take. Now remember, I'm taking this whole thing, so I'm going to put brackets around this. So I'm taking 1, and then I'm taking away negative sine squared alpha, so that is a plus. So how many sine squared alpha do I have? Sine squared alpha plus sine squared alpha is, that's right, 2 sine squared alpha take 1. Does this look familiar to us at all? You sure? That's our right hand side from the original proof. So we can say, once we reach that point, we can say, well, that's equal to the right hand side. So if we look at our nice progression here, we've had left hand side equals this, equals this, equals this, equals this, equals this, equals this, which is equal to the right hand side. So we can write QED, which is, I can never remember what it's for. I like to say it stands for quite easily done, but it's actually Latin for something. So, yeah, it basically means so it is proven. Alright, and that is a proof.